starting a little late, writing down the formulas. We have sine A cosine B minus sine B cosine A. Whatever they are. What about for cosine? Let's go ahead. So here's our sum and difference for sine. What about cosine A plus B? Here, the cosine together, and the signs are switched. If we're adding A plus B, then we're subtracting. Cosine, minus sine, sine. What about the difference? What about cosine A minus B? Sine A, sine B. We're adding them. The signs are switched with cosine. And yesterday, we learned a double angle identity. A different color.
Are we going to add to the sum and difference identities later? Yeah.
We will go on to tangent.
So just two more?
Yes. We'll have a whole separate section just for tangent. So yesterday, double angle identities. How did we get a double angle? What did that mean? The same piece. So A plus A. Whether it was 60 plus 60 or 45 plus 45 or whatever we need, we can use our sum and difference identities. Really, only our sums. Right there's a good place to stop. What if we need sine A plus A? What is A plus A?
2A.
2A. So sine 2A, if we have sine A cosine A plus sine A cosine A, what did that turn out to be? 2 sine A cosine A. So we had a sine A cosine A plus sine A cosine A. Ready to write it out?
Yes.
Okay. I did yesterday. Oh, my eraser is large. Okay, so this was an A plus A. Okay, that's how we got 2A. So this is an A, then this is an A. Okay? So A plus A is 2A. But then sine A cosine B, wait, our B is now an A, plus sine A cosine A. Are we multiplying?
No.
Sine, this is like, oh, I don't know, x times y plus x times y. What's xy plus xy? 2xy. Does that make sense? 2 sine A cosine A. Really, I'm not going to have enough room on this page. I can already see. What if we wanted to do cosine A plus A? So if I wrote out cosine A plus A, we would have cosine A cosine A. What comes next? Plus or minus? Minus. Sine A, sine A. Now we have a cosine A times cosine A.
Oh, it's cosine.
Cosine squared. And sine A times sine A. Cosine squared minus sine squared. Okay? Today, let's talk. We have a Pythagorean identity on the back of your plate. Are you good with that one?
It's squared because they're on the same side of the equation.
Cosine times cosine.
Okay.
Yes. Sine times sine. We have a Pythagorean identity somewhere. Yes? What is our Pythagorean identity that looks like this? What does it say? So my thought bubble says sine squared theta plus cosine squared theta equals 1. So if there's ever a subtraction, look at this. Cosine squared minus sine squared. And think, hey, guess what? That actually equals cosine 2a. Okay? So that's another thing we can put in for another thing. Okay? But now let's go up here to this. Is there another way to rewrite cosine squared? Could I write cosine squared?
1 minus sine squared theta.
Okay? So I'm going to take that cosine squared and I'm going to put it in. And we're going to have another formula. Okay? So if I put in, instead of cosine squared a minus sine squared a, I'm going to put in, I'm going to rewrite 1 minus sine squared theta minus sine squared theta. Does everybody agree the parentheses is cosine squared?
Oh, yeah.
This parentheses is cosine squared. Yes?
Yes.
So let's simplify. Let's pull the parentheses down. What's going to happen, Justin?
If you pull the parentheses down,
Yes, take them out. Can I combine? What can happen?
yes, then you get 1. Oh, wait. You
So
get
1 minus x squared minus x squared. Did we multiply? No, we are not multiplying.
you
How
get
can you do
How can I do what?
negative 2x squared.
1 minus sine squared theta minus sine squared theta. When you pull the parentheses, that's what you get.
So
How come
mean,
we
negative
pull the parentheses? That's never.
it's
we've
1
never been able to
minus
do
2
Yes, we
sine
have.
squared theta. Right?
When there are things inside and outside the parentheses that you can combine, you definitely want to take things out of the parentheses. Do you agree there's something inside the parentheses and something outside the parentheses that we can combine?
Okay.
Yes.
So 1
2 sine.
minus 2 sine squared.
1 minus 2 sine squared a.
But I was wondering if I could go get my calculator.
You don't need it today, I don't think.
Are you sure? So we're not doing homework then?
Probably not.
Okay, cool.
So is that not multiplication?
No,
It's
because
just
this was, we put it in right here,
Uh-huh.
and it was minus sine squared a.
Okay, so you're not multiplying.
I'm not multiplying. I don't need to distribute. I just am simply saying, hey, this is cosine squared.
Okay.
This is just cosine squared. That's all I want to do. Okay?
Okay.
Can I also, thought bubble, I will tell you why in just a moment.
So you want me to make sine to cosine?
Can I solve for sine squared in my thought bubble?
Yes.
What does sine squared theta equal?
1 minus cosine.
1 minus cosine squared theta. Okay, so I'm going to do that in green. Sine squared theta equals 1 minus cosine squared theta. Do you see a sine squared theta here that I could input 1 minus cosine squared for? Okay, so the third one would be cosine squared theta minus sine squared theta. What is sine squared theta?
1 minus cosine squared. So it's 1.
So in the parentheses, that really was our sine theta. So I'm just, I don't know. Giving you a hint, we're going to have 3 formulas for cosine 2a. Okay? So when you pull these parentheses out, technically, this negative 1 is going to distribute to everything
Why can we distribute this time but not last time?
because there was nothing in front of it to distribute it to. I just don't want you just to pull the parentheses and say, oh, it's cosine squared minus cosine squared, you get -1.
That's what I was about to say.
No! It's minus. Cosine minus 1
Two cosines.
minus negative cosine squared. What's minus and negative? Plus. You add the opposite. So 2 cosine squared A minus 1. You have 3 formulas. I'm going to make my eraser small. Maybe. It's not happy with me today for some reason. Go back here. So for cosine 2 theta, you have cosine squared A minus sine squared A. You also have 1 minus 2 sine A. You also have 2 cosine squared A minus 1. Okay? Sometime you might be given something. You might only be given sine. And you're asked to find cosine 2 theta.
Oh, what?
Which function would it be good to plug it into?
That
The one with
for
just
sure.
sine in it. I don't have to go find cosine.
Can we put these on our plates?
No, I'm sorry.
Why?
How are we
These
supposed
are
to
so
memorize
hard.
these?
Okay, the only ones you have to memorize are these purple ones at the top.
Okay.
Cool.
Well, I already know that.
Because you can make sense of the other ones.
And you only need these 2 to get all 4 of those at the bottom. Okay? Guaranteed. You need these up here. All the way to there.
I know those.
Good.
But I couldn't have got the ones in the bottom.
Yes, you could. Yes, you can. You will. You'll get there. So if I give you, you've written these down. If I give you sine theta equals 1/3, and we're in quadrant 1. I'll be nice. Okay? What is cosine 2a? You have the formulas right in front of you right now. Okay? What are you going to do?
Wait, can you go back? I didn't get.
Can I write all of them right here?
Yes, ma'am. I just didn't
Cosine
get the bottom two.
2a equals cosine squared minus sine squared. Cosine 2a also equals 1 minus 2 sine squared a. Cosine 2a also equals 2 cosine squared minus 1. Yes, ma'am.
So, does your A equal that, or do you?
Does A equal 1/3? No. What equals 1/3?
Sine.
Sine A.
So then what's the A? Oh, that's what you're saying. No, wait, no. I don't know. Wait, you want us to. So.
Is it bothering you that I put a theta and an A?
No. If you have.
Oh, well, okay, it's different color now. So which one of these 3 formulas over here do I want to use?
1 minus 2 sine.
We want to use this one. Why? It has sine in it. So cosine 2a equals 1 minus 2 sine squared a. And I give you, what is sine a? 1/3. Then we're going to square that, then we're going to multiply it times 2. So the only thing I'm inputting is sine a squared.
Oh, yes, it was bothering me because I was confused about why you had 2 different things. Okay.
So now, the hardest part for you now, after you figure out the formula, is do I remember PEMDAS? Do I subtract first? Do I multiply? Do I do exponents? So we need to do exponents. So what's our exponent? What's 1/3 squared? 1/9 times 2. 2/9. What's 1 minus 2/9?
7/9.
7/9. Cosine 2a equals 7/9. And you're done. Did we also have a formula? Refresh my memory. For sine 2a.
2 cosine.
No.
2 sine A.
Oh, 2 sine A.
Sine A, cosine A. Now, if I were to give you sine A equals 1/3, we're in quadrant 1. New problem. What is sine 2a? Sine A is 1/3. What is sine 2a? Please don't ever tell me just to double it. No. We have a formula. We're going to plug it in our formula. But, what's this piece? We don't have cosine, but can we find cosine? Yes. If you have sine, you can find cosine. And I'm not even going to tell you you have to use an identity to use it, find it. You can do anything you want. What divide by 2? 7/9. How much do you want to divide by 2? No. Oh, no. No, absolutely not. Cosine 2a, you cannot divide by 2 and get cosine a. It does not work that way. Does not. Just like we can't have sine a as a third and sine 2a is 2/3. No, not possible.
Wait, how are we going to find cosine?
You tell me. You know in your wheelhouse at least 2 different ways. Probably 3 different ways. You can use stuff from 5.1, 5.2, sine squared plus cosine squared equals 1. Jane Parsons says, no, please don't make me do it that way. What does she want to do? She wanted to draw a triangle. Where here is A opposite over hypotenuse is 1/3. What's this? What? Not 2. A squared plus B squared equals C squared. So 9 minus 1, we get the square root of 8. Or 2 over the square root of 2. So then can you find cosine A? Yes? What is cosine A? So we've plugged this in. We have the 2, we have sine A, and we have cosine A. And as long as we're still in quadrant 1, we're all happy because nothing changes. Yes. I did the Pythagorean theorem really quick to get the third side of a right triangle. I expect you to be a little bit quick on that. And then if I know A is here, cosine is simply adjacent over hypotenuse. Alright? So we're filling in this piece of our formula. To find sine 2a. And then you're just simply multiplying fractions. What's 2 times 1/3? 2/3 times 2 square root of 3 over 3.
1 square root of 2 over 9.
1 square root of 2 over 9. And nothing will reduce. All is happy.
So if it was in a different quadrant, you just...
If it had been in a different quadrant, the only thing that would have changed would have made our cosine right here possibly negative if it was in quadrant 2. Okay. And then means our sine 2a would have been negative. Okay.
If it was in quadrant 2, sine would be negative?
No, hear that, okay, I knew I said that. If this had been quadrant 2, okay, sine A is positive.
Yeah.
The cosine would have been negative.
Yeah. Because sine's positive in the second quadrant.
Yes, and the cosine's negative. But that would have been sine 2A would have been negative. Okay, now think about this. You've got an angle that's in the second quadrant.
Oh, then if you like.
And if I'm going to double that, it's going to go
not be in-
probably into the third or fourth quadrant, which sine would be negative. Thinking logically through that. Okay? So we're doubling something. I'm debating how fast should I go. Can we slow down and verify something? Do you remember verifying things? I can't go away from that. Could you verify simple things? Cosine 90 minus theta equals sine theta. So now we're going to use one of our difference. This is a difference identity. So we have to use that formula. So we need to practice on that formula. So I'd like to see you write it out. If you don't write it out long. Is this the distributive property? No. There's a formula for cosine A minus B. Yes? And when we verify, we really only want to work with one side if we can. The right side, there's really nothing to do with it. So what is the difference identity for cosine A minus B? So we have cosine A. So if cosine A is 90, we'll put an A there and a B here. Then cosine theta, that's a degree sign. Okay. Was it minus or was it plus? Plus. Keep going. What's cosine 90? There's a number there. Do you know? Can you turn around and look at a graph and figure out what cosine 90 is? Is it 0? Yes, it is. So 0 times cosine theta. What's sine theta? What's sine 90? 1. What's 0 times cosine theta? 0. This is just a big fat nothing. What's 1 times sine theta? So does sine theta equals sine theta? Yes, it does. Does anybody recognize that formula that we started with? 90 minus theta. So I'm going back a long way. What's 90 minus theta? What's cosine 90 minus theta? Sine 90. Sine 90 is 1. Is that the one you're talking about? We turned around and looked at and said sine starts at 0, 0, 0, but at 90 degrees it's 1.
So where did sine 90?
In our formula, cosine A, cosine B, plus sine A, sine B. And my A's and B's were 90 and theta. Do we need to plug in some numbers here? Okay, you're gonna make me. Cosine 90 minus 30. Will that equal? Verify that for me. Means use the formula, go the long way. But why did I pick 60 there? Oh, stop. It's not 60. My theta changed. My eraser is small.
Yeah.
So thetas have to stay the same. This theta and this theta have to be the same. So you've got a formula. We're plugging in. What's cosine 90? Times cosine 30. What's cosine 30? which is just gonna be 0. It doesn't matter
It
what
doesn't matter
what we put there. We're gonna multiply times 0. So sine 90. Sine 30. Really, I don't even want numbers. Let's just leave it without numbers. Why? Exactly.
Oh, because it's 1 times sine 30.
So no matter what I put right here, it's going to multiply times 0. Times cosine 30. We don't even look at triangles. What's sine 90 again? 1. 1 times sine 30. This is a big 0. This is simply sine 30. What's 90 minus 30? 60. So you're telling me that cosine 60 equals sine. They're what, Ryan? They are co-functions. You just verified, I was in geometry, I would say proved, co-functions. Yes, she definitely said it. Yeah. Okay. So if I wanted, I could put other things in there. Yes? Sure. We have a whole, like, 5 minutes. I don't know. But we haven't had it in a real class in 2 weeks. This is our first real class, full class, regular schedule in 2 weeks.
Really?
Homecoming week last week we did not have.
Well,
Monday was.
Was it?
Monday was normal, I thought.
I don't know. It feels like Monday something happened.
Yeah, you're right.
I mean, there's like the morning prayer schedule, so it's like a little bit different.
Yeah.
But
But it wasn't shorter.
It wasn't short. It's the same. Okay.
feels like forever ago.
Yeah.
It's
It's
been a
been
long
It was
weird.
skate night and
Oh, so no
something else.
home.
Oh, yeah.
So there was no home.
So
I
there
don't
wasn't
know what
homework.
happened. What if I ask you what is sine 180 degrees minus theta?
But I'm having a hard time hanging today. Me too, because it's so.
A lot of
feels
people will.
And I woke up so tired. I've been doing okay for the past like week or so. But today I was like,
put in the party card yesterday on your half day off.
I didn't. I went shopping.
My mom bought broccoli and we laid that game for hours, and I did not play. It was not fun.
Garrett bought America-opoly in DC when we went, so we had to play.
It's fun unless you don't win.
The question is, do you trade? Are there trades allowed for properties and buyouts?
You can, but it's
So
like
we're not verifying that one.
You're not verifying. I just want to know, what expression do you come up with?
Oh,
Can you solve it? No.
you can't solve it.
No, you can't solve it. There's
You
no
just put
equal
it in
sign. There's
the-
no equal sign. But you can substitute, like if you have
That's fine.
sine 180, do you know what sine 180 is?
Okay.
Do you know what cosine 180 is?
I can't see.
you know what I got?
Hey,
Well, you should have gotten something.
I got
What?
sine.
I don't know. We should put a poster up here.
We should put a poster up, but it worked nice that there were 4 there. Because I usually put 2 there, and I was going to put 2 over there. And then my Christmas
I
tree.
think it's 0.
I put 1 right there.
Why do I?
So let's go. Let's start working through.
I got 0 minus 0.
What is our sine
Oh wait, I
equation?
got
So
negative.
I said 80 cosine.
Okay. So here we go. Sine theta. Sine A minus B. What are you doing?
Sine 180 cosine theta minus sine theta cosine.
Minus. Okay, minus what?
Sine theta cosine.
So what is sine 180 now that you've gone over there and figured it out?
0.
It's a 0 times cosine theta.
so this is
Minus.
negative.
And that
What is
is 1.
cosine 180?
Negative 1.
It's negative 1.
So
It's
like
negative 1. So this is 0. So I thought, yeah, it might be
minus
negative.
a negative sine theta, which is just sine theta.
Woo, I did it. Okay. Using the formula. No, it's not too much.
This is a lot
Wait.
easier than last week.
Good.
Oh,
wrote something crazy. I forget that they do this. I'm like making sure I've done everything.
I spoke too soon.
But the it's not hard. The co-function thing, they've done that. No, they do 2 more little things. What about if I write something cosine 87 degrees?
Now I'm allowed to use my calculator?
No. We're not going to use calculators much.
Alright.
So, this is kind of where we started with the worksheet. Okay?
Oh.
Can we go backwards?
Hey.
Can we go backwards? Wait just a second. You have a question, or are you going to tell me an answer?
You want the exact value? Like, you want the exact value. So,
What is this?
I go back.
What is this number right there? 3.
Number.
Is that a 1
Yeah.
and a 0?
Yeah.
And a 0. How did you get that?
Okay.
Okay, so that's better. So now, yes, I want an exact answer.
Hey.
Oh my goodness.
Oh,
What do you want us
goodness.
to do with that? Put it into that.
Yes, now can you add those 2 numbers? So you,
Hey.
are we, did we all go backwards? So we just simply did equals cosine, because you figure out it's a cosine function because it's cosine, cosine. Your A and your B, what do we do with them? A plus B. Oh wait, what is our A and our B? 87 plus 93. What's 87 plus 93? 180
So it's just zero.
degrees. Cosine, what's cosine of 180 degrees?
Just kidding, it's -1.
Wait, wait, sine I thought was 0.
It is.
Your answer is -1.
I like that one.
I don't know why you wrote
That
it.
was great.
I don't know. You just added 7 to the 93 and forgot about the other 80. I don't know. Okay? So if I give you something like that, you recognize it's cosine, cosine, so it's a cosine function. There's subtraction sign, so I'm going to add them. That's just can we go backwards?
That was fun.
That was fun.
like this one.
All right.
Just a little.
Okay, what if I asked you, go back to cofunctions. Do we remember cofunctions again?
Yes, ma'am.
All right.
Is that where they're equal with each other, the sine and cosine?
Yeah, so sine 90 minus theta equals cosine theta. We could write all of them. If we have cosine, well, when we just did a little bit ago, cosine 90 minus theta equals sine theta. These are just cofunctions. We just verified this one.
The 90 minus theta. I don't remember this. I
just did that.
vaguely remember it. I remember that for today, but not like the past.
Whoa. Right there. Oh, no, one more. Sorry, transitions. Cosine 90 minus theta. We just verified that that actually equals sine theta. It's a cofunction. Sine and cosine. Okay. What about tangent and cotangent? What about secant and cosecant? Those are your cofunctions.
So we have 1 to 180 degrees.
No. No. So could I write tangent 90 minus theta equals what?
Cotangent theta.
Cotangent theta. And I could reverse that. So, a little hint. There's another thing you could write here for cotangent. Cotangent you could really rewrite as tangent 90 minus theta. Or, instead of 90 degrees, could I get really crazy and put a pi over 2 there? What is pi over 2? 90. So could I write cotangent 90 minus theta equals tangent theta? These are just your co-functions. Okay? Are there still more? Let's go ahead and do it. If we're writing them. Equals cosecant theta. theta. Or cosecant 90 minus theta. Not 90 minus theta equals secant theta. So if I ask you to rewrite, or that says find an angle theta that satisfies each of the following. You're finding a theta, you're going to have to use cofunctions. Cotangent theta equals tangent 25 degrees. What is theta? Guess which one I'm going to use? Can I rewrite cotangent simply as tan 90 minus theta? Can I do that? Yes, this is another way to rewrite cotangent theta in terms of tangent.
But that one says equals cotangent theta, and over there it says equals tangent 25.
Can I plug something in for cotangent? Cotangent equals this. So wherever I see cotangent, can I put in tan 90 minus theta? That's all I did. And so now, can I solve for theta?
Yeah.
Tan 90 minus theta has to equal tan 25. So these things I've underlined have to be equal to each other. So I'm simply saying 90 minus theta equals 25. There's degrees there. I need to do better. So theta equals, what's 90 minus 25? 65, you tell me?
Yes.
So cotangent 65 equals tangent 25.
Wait, I wrote down.
And then you made that.
I wrote cotangent down. So really, it's just complementary functions.
Oh yeah, that's the same thing. But it's not tangent 90 minus 25. It's not cotangent, it's tangent 90 minus 25.
No.
It's your point.
Let me go hit the stop button.
Let me show you.